Hey guys, and welcome back to a new video. In this video I will show you how to implement Work Manager in your Android apps. By the way, I have made a video about Work Manager where I explained Work Manager in only 1 minute, so I recommend you to watch that video first, and you can click on the exclamation mark that shows in the top corner of this video right now. Watch that video, then come back and start with this video. Okay, now I suppose that you watched that video, and before we implement Work Manager, let me actually demonstrate to you when you actually need to use it. Let me give you a real example from a real app. So let's actually jump into the monitor to show you that. And right here I got my phone where I will actually use Facebook Messenger to send a message to myself. So as you know, when we send a message without internet connection, of course that message will not be sent. And when we restore the internet connection, the message will directly be sent to the user. And that's because the message will be enqueued inside the Work Manager database, and when the phone restores the internet connection, Work Manager will directly send the message. Let's actually demonstrate that. Okay, here's Facebook Messenger. I'm gonna send a message to myself and I'm gonna cut the internet connection. I'm going to send hello. Now as you can see, the message is not sent yet. Now let's exit the app and let's reconnect to internet and wait some time. The message will directly be sent. As you can see, the message has been sent when we restored the internet connection. And this is a simple example when you need to use Work Manager. And there's another use case that I will cover in this video, so make sure to watch this one until the end. Without any further to go, let's actually jump into Android Studio and implement Work Manager. Okay, and welcome back. So first, let's actually add the Work Manager dependency. So open up your browser, go to Google, and here search about Work Manager dependency. Scroll down, and as you can see, there are a bunch of dependencies in here. As I said, Work Manager will do your work in the background, and that's why you can find Kotlin with coroutines, and you can also find another library for RxJava. And there's one more library for Java which will handle the background work with a thread. But for us, we will use the Kotlin with coroutines dependency. So make sure to copy this one, go to your Android Studio project, the Gradle build file, and paste the dependency in here. So I've already did that. And you also want to copy this variable, which is the Work Manager version. So copy it and paste it in here. Then click on Sync Now and you are ready to go. Alright, now in order to work with Work Manager, there are two basic steps that you want to do. First, you need to create the worker which define the background work you want to do. So in our example, we will send the message. So our worker is going to have a function to send the message. And the second step in Work Manager is to enqueue your worker. So let's start with the step number 1. So let's go ahead and create our worker. So create a new class for that and call this send message worker. And in here we're going to extend from the coroutine worker. So as I said, we want to use the Work Manager API with coroutines. There is also worker, so this will just handle your worker inside a thread, but with coroutine worker it will handle the background work inside the coroutine scope. Okay, so now in here we need to pass some parameters to the parent class, and we just can get him in the constructor of our class. First, we need to get the context, the application context, and there's something called the worker parameters. So the worker parameters here will send extra data to our worker. You will see that later in this video. So now in here we are required to pass these data inside our parent constructor. So first let's pass the app context and the worker parameters. Then inside here we're required to override the doWork function. So as you can see, I'm gonna override this one. And since we use coroutine worker, as you can see, this function is a suspend function. So we can run a long running operation inside this function. We can call any suspending function inside this one because it's a suspend function. So inside here we're gonna send a message. Well, I'm not going to send a real message, so we're gonna simulate that. In here I'm going to add a delay for, let's say, 2 seconds, and I'm going to print a message that the message was sent. So we're just gonna simulate that. And as you can see, this function needs to return a result. So let's actually return that. And now there are different options. So the first one is the result.success, which means that the worker is finished and it's actually done. And there's another type of success which receives output data. So this one used when you want to execute many workers in sequence and the workers depend on each other. We will use this in this video and you will see that also. We have success.retry. This used if your work was failed and you want to retry to do it. And there is also result.failure and there is result.failure with output data. So you can use this one to send the error. So in our case, we will use success because we can say that the message is always sent. So that's it for step number 1. Now in step number 2, we want to define the work request and enqueue it inside the Worker Manager API database. So to do that, we're going to do it inside the main activity. But in your case, you might do it inside the view model. So you need actually to take care of that. Okay, so let's create that. In here, we're going to define the work request. So let's name this send message work request. And now there are two types of work requests. The first one is one-time work request, which will basically be executed for only one time. And there is a periodic work request, which is going to execute periodically depending on the period that you give it. So let's start with the one-time work request and now call the from function. And in here you need to pass the worker class, which is send message worker, and that's actually it. Now to enqueue this worker inside the Work Manager database, we need first to get an instance from the Worker Manager. So to do that, val work manager equals to work manager dot get instance. In here you need to pass the context. Now inside the create function, in here I actually use Jetpack Compose. In your case, you can use XML, which is gonna have a button with a click listener. So let's actually do that. Set content. I would like to put that inside a box. Give a modifier of fill max size and content alignment center. So we can center that button inside the middle of the screen. And now we're gonna have a button. We will implement the uniclick later. So inside this button, we will have a text, send message, and inside the uniclick, in here we just need to enqueue this work inside the Work Manager. To do that, it's very simple. We can call work manager.enqueue and we can just pass the send message work request. And now each time we click on the button, this work will be enqueued inside the Work Manager database and it will be executed in the background even if the app was closed. So let's actually run that to check it out. Okay, now let's open the Lookcat and let's click on the send message button. Wait 2 seconds and as you can see we got this log message was sent. Now let me show you one thing. Let's actually go to the worker and let's increase the delay in here, make 3 seconds and let's launch the app again. Now I'm gonna click on the send message and exit the app. So I'm gonna terminate the activity and as you can see we did not get the message and it's because we actually stopped the app while we are inside this delay function and we did not complete the whole function. We did not reach to this line. So how to give this function more priority even if the app was closed? We don't want to finish this function until its end. So to do this, we can convert this worker into a foreground service. So as you can see, a foreground service has more priority inside and it will not be killed if the activity was killed. And if you are familiar with foreground services, you know that we are required to show a notification for that foreground service. And that's why we need to define our notification. So we first need to define our notification channel, and for that I would like to create it inside the application class. So let's go ahead and create a new application class for our project. Let's call this send a message application, and let's extend from the application class, and we're gonna do that inside the unicreate function. So inside here we're going to check if the version of the device let's import build.sdk is greater or equal the Oreo version, which is API level 26. So just can type 26 in here. And in here, we're gonna just define our channel. So val channel equals notification channel. And inside here, we need to pass the ID of this channel. So I will name it send message. And the name of the channel. Finally, the importance. Just can give it default. And we want to get the notification manager first. Notification manager. Get system services. In here we can pass the notification manager class. And finally we can use that to create our notification. Now go back to the worker. In here we can define, or we can create a function for our notification. So let's call that, let's make it private actually, and call that get notification. And this one returns a notification. So let's actually create that notification from the notification compat, call builder, and we need to pass the context. Let's actually make this private val so we can use it. Pass it inside in here, and also pass the channel ID. We call that send message. Let me make sure. Okay, the S letter is a small letter, so I'm gonna change that. And in here, we're gonna just add the properties of our notification. So set content title, sending message, set content text. Let's say your message is sending, and let's add small icon. I will actually add any icon from the drawable file. So this one, for example, and finally we build this and we're gonna return it. Now, in order to show this notification inside the doWork function, you need to call the setForeground function. And as you can see, this one receives an object from foreground info. And that's why you can override this function, which called foreground info, get foreground info. In here, we can actually return this object. So let's do that. We can return foreground info. In here, we can pass the notification ID, which is 1, or you can add any ID you want, and we can pass the notification using this function. So get notification, and finally we can call this function inside the setForeground. So get foreground info. And that's already it. Now let's actually launch the app and see if we can still get the look at even if the app was killed. Let's click on send message. I think we forgot to do something actually. We need to add the application class inside the manifest. Yes, so let's add that. And now we can launch the app again. Let's go here, send message, exit the app. As you can see, we show the notification, and in 3 seconds we should get the log. Okay, let's see. We have not get it yet. Let me filter it actually. Message was sent. Yes, here it is. So as you can see, we got it. Let me do that again. I think it was unclear. So I'm gonna clear all the logcat, launch the app again. And I'm gonna click on send message, terminate the app. As you can see, we show the notification. We wait for the log, and as you can see, we got the log in here. Message was sent, even though the application was killed, because we made this class to act like foreground service. Alright, now let's move to the next topic. Now let's take this use case. Let's say in a real app, you have a messaging app that takes the message from an edit text or text field. So let's actually simulate that. Let's actually create a text field inside this box. I would like to create a column in here, and I'm gonna put this button inside here. But before this button, I will create an edit text. Sorry, it's called text field in Compose. And for the value, let me actually have a state first. If you don't know Compose, you can do that with XML. It's actually the same. So in here, we're gonna have state. And we're gonna import both of these. And now we can pass the state in here. On value change, we can change the state. Let's launch the app and see that. Okay, now when you work in a real app, let's say you're working on a chatting app, you actually need to take the text from the text field and then send it to this class to send the message inside here. So how we can do that? How we can send input data to this class? It's actually a little bit different than this way. So we need actually to delete this work request, because this time we're gonna define our own work request. We're gonna use the builder pattern. I will show you that. So in here, we actually need to create our work request inside the onClick function. Let's do that. So val send message work request. And I will explain the periodic time work request at the end of this video if you are wondering. Now, this time we're not gonna use this one actually. We're going to use something similar, which called runtime work request builder, this one, because I said we're gonna build our own work request. Inside here, we are going to pass the work class, which is send message worker. So to send input data, we can call send or set input data, and inside here we can use the work data of. This object acts like a key value, like a hash map. So the key in here is a message, and the data is our state, because that's what we're gonna send to the worker. So we're gonna give that in here. And now I want to also show you how you can set conditions or constraints. So, you know, when we want to send a message, we only want to send that message when we have internet connection. So how to set conditions or constraints? Well, there's a simple way to do that. So we can just call set constraints function. In here, we're gonna build a constraint object. So constraint or constraints dot builder. We remove the constructor braces. We call the builder class. And now we can actually set the constraints after the builder. And in here, there are a bunch of constraints. Let me show you them. We have the first one, set required network type, which is we're gonna use. There is set requires charging, so it will only execute your worker when the phone is charging. Set required battery not low. Set required device idle. So there are a bunch of constraints that you can check it out. But in our case, as I said, we're gonna use the network constraint. So let's use that. Inside here, we wanna define the network type. In our case, all the network types. So network type connected. So as long as we have internet connection, we can send the message. After that, we wanna build this constraint object. So let's actually call so we can call the build function. And finally, we can build this request. So after the set constraint, we can call build to build this request. Now, finally, we can enqueue that inside the Work Manager instance. And we can pass the request. Okay, now let's go to the message worker class and let's receive the data that we sent. And to receive them, we can use the worker parameters that I told you about. Let's make this private val and let's get him in here. So val message text worker parameters dot input data. As you can see, we have a bunch of things in here. We need the input data, and in here we can get a string. So this is like a bundle. We can give the key, which is message, And if this null, because this might be null, we will assign this text message is null. Inside here, inside the print function, we're gonna add the text with the message. So message text. And now we can run the app to see that. I'll open the lookat. We are going to type hello from land of coding, send the message. We got the notification. We wait 3 seconds and I'm going to filter that message. As you can see, we got this message in here. So message was sent, hello from land of coding. So that's how you can send input data to your worker. Now let's try a new thing. Let's close the app. Let's cut the internet. And let's try to send that message. So this app, let's type hello and send that message. Now as you can see, nothing happened. Why? Because we actually set a constraint in here, the network required constraint. So this will not actually work until we have internet connection. Now if we turn the internet back and wait some time, the worker should be executed automatically. As you can see, we didn't click on the send message, so the worker wasn't queued, and whenever we have the constraints available, we can just execute, or the work manager will execute our work automatically. We don't need to re-click on the send message, and that's why we said that work manager used to do reliable work. Okay, now moving to the next topic, which is how to handle the progress. So let's say you are downloading a file, or in our example, you are sending a message and you want to show a progress bar to the user. You want to show the state of that message. Let's go to the send message worker, and inside do work class, we have this function set progress. So this will actually set a progress of your work, and we're going to add a key value in here. So let's let's add loading 2, and I'm gonna pass true in here. And after the message is sent, we can copy this, paste it in here. We can send false, because in this case the loading is false. Of course, the message is sent and we want to just hide the loading progress bar. Now let's get back to the main activity to observe that state. Let's see how to do that. First, we need to have a state for the loading case. So var loading by remember, and we make this mutable state of false initially. And we also need a state for something called worker ID. So let me show you that. And this state is from the UUID class, which is a class used to generate IDs. And initially, let's make this null. Now, one thing you need to know is that each work request has a unique ID, has its own ID to be observed and to be. Now, one thing you need to know is that every work request has its own ID. So this send message work request has an ID that used to get the progress and to get the state of the worker. So to get that ID, we can actually assign it to this state. So worker ID equals to send the message work request dot ID, and finally we want to show a progress bar only if this worker ID is not null. So if it's not null, then we know that it has an ID and it has a worker. And now below this button, we want to show the progress bar. So we only want to show the progress bar if the loading state is true. So we check that. If it's loading, then we can call the circular progress indicator. So this will make sure to show a progress bar only if the loading state is true. Okay, now we're not done yet. We actually need a way to update the loading state. So to update the loading state, we need to observe the worker state. So how to do that? We can actually do the following. First, we want to check if this worker ID is not null, because that's what we're gonna use to observe the worker state. So worker id.let. Inside here we will get the work info. We will use the work manager class or the work manager object, and there's a function called get work info by id livedata, and in here we can pass it. As you can see, the work info here is a live data, so we can observe that live data to update the loading state. But in Compose we don't need to use live data. That's why I have this dependency for you, which will convert the live data into a state. So make sure to include that. You will find it in the description. And in here we can now call the observe as a state function. This will make sure to convert this work info into state. And now we can get the value of that state. Now finally, in here we can check if the work info is not null, because this is nullable. And we can finally change the loading state. So we can get the work info dot progress dot get boolean, because in here we send a boolean. As you can see, we send a key value of boolean, and the key here is loading. So that's what we're gonna pass in here. We're gonna pass loading, and the default value is false. And that's already it. Now if we launch the app, we will be able to see a progress bar when the message is sending, and the progress bar will be gone when the message is sent. Let's check that out. Let's type anything, hello, send message. As you can see, we show a progress bar in here. After 3 seconds, the progress bar will be gone. So this is how you can listen, or this is how you can get updates from your worker to your UI and show a progress to the user. Okay, now moving to the next topic, which is a chain of workers. Now let's take this example. Let's say you want to download an image, then you want to apply a filter on that image. After that, you want to save it into the storage. And you also want those tasks to happen one after another one. And in this case, you need the output of the previous task. And luckily, Work Manager makes this easy for us. We can actually define a chain of workers to enqueue them as we did previously. So let's see how to do that. In here, I'm gonna actually delete these things. So I'm gonna delete this and the loading here, and also the content of onClick. And I'm also going to delete these states. I think we also can delete the text field. We don't need that anymore. Okay, now let's take that example. Let's actually define 3 workers, because as we said, we need to download an image, apply a filter on that image. After that, we want to save it into the storage. So each task needs to be executed inside a separated worker. Let's create, first let's actually delete the send message worker. And let's create 3 workers now. The first one is download image worker, extend from routine workers, and we want the app context and the worker, here val. We also need the worker parameters. We need to pass them inside here and implement the do work function. I'm gonna copy this one, paste it one time in here, change the name to apply filter worker, paste it one more time for save image worker. Now inside the download image worker, we can add a delay of 2 seconds. After that, we can print ln image downloaded. So we simulate that by printing it. Then we can return result dot success. But this time we need to send input data for the next worker, because when we want to apply a filter on the image, we need to know which image that we want to apply the filter on. And that's why we can send it as output data inside the success function in here. So let's do that. work data of, the key is image, and we actually can just generate any ID for that image. And inside the apply filter, we want to receive this one to apply a filter on the image. So let's actually do that. Val image name, worker parameters dot input data dot get string. The key is the image, and if it's null, we can say that image not found. Then we will add a delay for 2 seconds. We will print applied filter, and we will also print the image name. Then we also need to return result.success, and we also need to give output data for the next worker, because this worker needs to know which image we want to save. So in here we can just add work data of, the key is filter, and the value is image name. Inside the save worker, we can do the same thing. So we want to get the image name, input data, get string, the key is filter, and if it's null, we can say that cannot save image. Or we can actually return, for example, result.fail, and in here we can add a delay for 2 seconds, then print that the image was saved. Finally, we return result.success. Now let's go to the main activity. We want to have a work request for each worker. Let's actually do that. Val send message work request. We're gonna use runtime work request dot from. We will not set any constraints, so we don't want to build our worker. We're just gonna use a simple work request. In here we need to best download image worker. I'm gonna copy this line or duplicate it for the apply filter worker. And one more time for the save image worker. Now we want to create a chain out of these workers requests. So to do that, we are also gonna use the work manager object dot begin with, which will receive the header of the chain. In our case, the first one that we want to execute of our chain is the send message work request. Now let's say we use this one. So send message work request, and now to define the second node of our chain, we use then apply filter request, then save image request, and finally we want to enqueue this chain using the enqueue function. So what happens now is that all these workers will be executed sequentially. They will actually contact to pass the output data between each others. So let's actually run the app to see that. Let's go to the logcat and let's click on send message. Let's delete the filter. Okay, as you can see, image downloaded. We got that. Then we show apply filter, and there's the name of that image, and then image saved. And this is the name of the image that was saved. Now let me show you this thing. Let's actually click, let's actually spam this button. Let's click like many times. Let's see what's gonna happen. As you can see, we got a bunch of workers that works in the background. We actually enqueued the new chain for each click, so we got a bunch of lookcats in here. If you wanna cancel this behavior, if you wanna determine what happens if we click multiple times, or if we request or if we enqueue many chains of the same chain, let's say, we can use the begin unique work. And in here you need to pass the work name. So let's say image. And in here you need to pass the existing work policy. So let's see what's that. So as you can see, we have a bunch of options. The first one is append, which will actually do the same behavior that we saw. And this one will actually keep the current chain, but it will cancel the one that just came. Replace, it will do the opposite. So it will cancel the one that is running right now, and it will start executing the one that was clicked now. And append or replace, actually this will act like append. I'm not sure what is the difference, but I think in most cases you need to use keep or replace. So let's actually use keep, and let's we need to actually create our chain now. So we need to pass the send message worker, then apply filter work request, after that the download, or sorry, the save request, and then we call enqueue. Let's launch the app and let's spam the button now. As you can see, I clicked many times, and as you can see, we only printed it one time. Image downloaded, we printed, applied filter, work, result, success, because as we said, we used keep policy. Now the last thing I want to show you is the periodic time request. Let me delete this, and this one, let's make it periodic work request builder. In here, as we said, we're gonna pass the download image worker. By the way, this should be download work request. And as you can see here, we are required to pass the duration. And as you can see, you have of days, of hours, millis, minutes, second. So one thing you want to know is that the minimum interval is 15 minutes. So you can just do your workers every 15 minutes. But in our case, let's actually say of hours. And let's say 1. And this requires a minimum API O, which is 26. This is API level 26. It's okay, you can add that annotation in here. So what this does, it will execute your worker every hour. This is useful if you want to sync your user's data with the server, for example, each 2 hours or each, let's say 12 hours. So this is the use case of periodic work manager. If you want to just sync the data sync your user's data with the server, you can use periodic work request. Okay, so that was it for this video. I know this might be a long video, and if you watch until now, I could say congratulations, now you know everything about Work Manager. You can work with Work Manager in your project. And if you want to follow me on my Instagram page,